welcome back. All right, we are on lesson 3 and we're solving proportions. Okay, we have two ways of writing a ratio. So if I'm looking at the first one here, right, I can write, there's 3 circles, right? So for every 3 circles, this is a 3 to 5 ratio of circles to triangles. Or I can write it with 3:5. So what is the ratio of circles to triangles? Well, circles are the 3 and triangles is the 5, right? The number of circles is what fraction of the number of triangles. So it's, if I'm going to write a fraction, it would be, it's 3/5, so 3 of 5. All right, so if I was looking at these bottom questions here, now notice I didn't say of shapes, I said of triangles, right? So the number of circles is what fraction of the number of triangles, 3/5, right? I didn't say, those are part to part fraction. That's important. All right, so we sometimes write ratio using the same notation as fractions, even when the ratio is part to part and doesn't represent a fraction. So I can write this part here as a ratio, which would be 2 to 5. And then if I needed to write it as a fraction, it would be 2 of 5. So 2 of 5 would be circles. And it's a comparison. Okay, so how would I write the next 2? Pause the video, please. So that would be 2 to 3. And then if I needed to write it as a fraction, and this would be 4 to 1. Okay, so for example, if a zoo has 2 zebras, right? For every 3 monkeys, so I have 2 zebras for every 3 monkeys, we could write the ratio as 2 of 3. This does not mean that the zebra has 2/3 of any set. What it does mean is that the number of zebras is 2/3 the number of monkeys. So the ratio compares the numbers, not the sets. So we can write even part-to-part ratios as fractions. Okay, so ratios, well, I want to recall that a fraction is just a number. So we can think of ratios as numbers too. When we write the fractions, so I have 1/8 here, right? If I were to write these fractions here, so I have 2 over the denominator of 1, 3 over 1, and 4 over 1, we would write these just as 2, 3, and 4. So just like we would do the same we just remove the denominator, we don't write that denominator. Similarly, if we compare a number to 1 as a ratio, so 8 to 1, we could just think of the ratio as being equal to 8. The second term of the ratio is like the denominator of the fraction. Okay, so the second number of the ratio is like the denominator of the fraction. One difference between a ratio and a fraction is that a ratio can compare any number to 1. Okay, so for example, 2.7 over 1, this is not a fraction. Okay, this is not classified a fraction. You are not allowed to write decimals over in fractions as a numerator or a denominator, okay? But it is a ratio, okay? So I can write 2.7 and compare it to 1. So if I had a ratio of 7 to 2, this is equivalent of 3.5 to 1. So you can think of 7 to 2 as the number 3.5. Okay, so We're going to get into this a little bit more, but these are equivalent fractions, right? Because 7 is double that. So when we reduce it down and compare it to 1, the ratio can be just 3.5. Okay, so we're going to look at this a little closer now. Okay, I have a ratio of 5 to 4. If I want to find an equivalent ratio where the second term is 1, and then I write it as a number. So I want the second term to be 1, and then I write it as that number. So what do I mean? Well, I'm going to divide both of these numbers by 4. Same as if we were looking at fraction. If I had this as a fraction, whatever I do to the bottom, I do to, that's not a plus, I do to the top of the fraction. So I'm going to do that to my ratio here. So this would be 5 divided by 4, right? The top there. And then 4 divided by 4. And now this is all going to be equal to 1.25, because the answer here is 1.25 to 1. Or we can just say 1.25. That's the ratio. Okay, so I want you to pause the video, or I want you to be doing this with me. Okay, so I take this number here, okay, and I'm going to divide both numbers by that. So 7 divided by 5 and 5 divided by 5, so that we can get it compared to 1. So 7.5, or 7 divided by 5 is equal to 1.4, and now that's to 1. And now we can just write this as 1.4. That's the ratio. All right, so this is, again, 6 divided by 8. And this is going to be 8 divided by 8. And now this is going to be equal to 0.75 to 1, which is just 0.75. So you can leave it in either of these forms. All right, now what I'm going to do is I'm going to take these here and I want to order them. Okay, so in order to order these, I'm going to put these in order, and I'm using this part to show where would it go on a number line. Okay, and I'm going to write it from the smallest one to the largest. So looking at the ratios, it's kind of hard to tell, but I'm going to kind of explain that in a sec. So looking at these numbers now over here, obviously, okay, that one is the smallest, right? Then we're going to compare these, and 5 to 4, and then 7 to 5. All right, these numbers has a bigger on this side, so obviously it's going to be smaller because we're dividing by that number. Okay, these ones are closer together, so there's likely going to be smaller than this one where there's a bigger gap there. But if you reduce them down like this, you'll be able to see it very clearly. Most people won't be able to do it by this. Okay, so you're going to need to know how to do it from smallest to largest. Okay, so a proportion is an equation that shows two equal or equivalent ratios. Okay, remember we were talking about equivalent, right? So looking at our ratios here, remember I said whatever you do to one side, just like the fraction, you do to the other side. So I'm going to look at the fraction here. If I am going on the numerator to 6, I would multiply by 3 here, right? So I'm going to multiply the denominator by 3, and I would get 9. If I was going to go to 6 here, I'd multiply by 3. So I have to multiply this one by 3. And I would get 9. So this would be a 6 to 9 now ratio, and these are still equivalent. Okay, looking at the fraction again, in order to get to 28, From 7, I would be multiplying by 4. So I have to do the top by 4. So same here. I multiplied by 4. Oops, wrong one. Okay, so I would multiply by 4. And so this would be multiplied by 4, which is 16. Okay, again here, I'd multiply the numerator by 2 to get to 24. So I'd have to multiply the denominator by 2, and I would get 10, so it would be 24 tenths. Now, to get from 12 to 24, I'd multiply by 2, so I have to multiply this by 2. Okay, so this would be different ratios, but it's easier to see when you're writing it as fractions. So if I'm looking at this, we're going to need to multiply, right? And I'm multiplying from right to left here. And from here, I would be multiplying, if I was looking at this one, I would be multiplying left to right. It doesn't matter. Okay, so something times 9 is going to give me 27. I know that's times 3 because I know in my times tables. Or if I wasn't 100% sure, I go 9 plus 9 plus 9 until I hit 27, right? And so that would be 15. Okay, over here, I've multiplied by 7, so I need to multiply by 7. Okay, so if you're unsure again, what 6 times 7 is, you could go like, what 6 times 6 is 36 plus another group of 6. Okay, it would be 42. And this here is multiplied by 4. Okay, and I multiplied by 4. Same thing, if you weren't sure, count by 5s. 4 times 5, 10, 15, 20. So this would be 20 over 16. Okay, I'd like you to do the ones on this side. And I'm just going to fill them in. So make sure you just hit pause. And I'm going to fill them in, and I just want you to double check. Okay, so this would be 10. This would be 6. So that would be 12. And this would be 4. So this would be 44. All right. Now, you can also divide as well, right? So here, I'm still going to multiply. So I'm going to go, this is 6 multiplied by 2. Okay, multiplied by 2 here. And that is going to give me, that is a 2. It's going to give me 10. Okay, I have multiplied here by 6. So this is going to be 12. Okay, do these ones for me. All right, so how did you figure this out? Well, you can either say I multiplied by 4 or I divided by 4, because multiplication and division undoes multiplication, right? So if I divided by 4 here, I'm going to divide by 4 here. Gives me 2. All right, over here, how much did I divide by? Or I can say, how much did I multiply by 4 to get 8? So you can just do one or the other, and then you just know that you divide by that much. So I've divided by 2, and that would give me 3. All right, do these questions by yourself. Divided by 4, so this is 5. Okay, I divided here by 2. Oh, I multiplied by 2, sorry, blah, blah, blah. I multiplied by 2, this gives me 10. Okay, I multiplied by 5, I'm going to multiply by 5. And I multiply by 2, so I'm going to divide up here by 2. So you have to think about which direction I'm going. I'm going smaller, so I'm going to need to divide. I'm getting bigger, so I'm going to need to multiply. All right, so I need you to stop and just do to question 3. They're written as ratios, but it's done in the exact same way as we just did it with fractions. So making sure that you do to number 3, you're understanding.